If you like rocket launches, then this video is for you. Today we're here in Barra do Pirai, in Rio de Janeiro, for the Brazilian rocket journey. It's the final stage, the grand final of the Brazilian Rocket Olympiad, which is part of the Brazilian Astronomy Olympiad. The Brazilian Astronomy Olympiad. It's been a year since Manuel do Mundo introduced a new rocket category here at the Brazilian Astronomy Olymp, which is multi-stage rockets. It's like a rocket that carries another rocket, and the rocket's separate in the air. This is very similar to what happens with real rockets. So, we officially launched the category, made a tutorial explaining how to build it. But did it work? Did anyone actually manage to make a rocket like this that went far? Just so you have an idea, 8,743 students signed up for this category and launched their rockets. There were 577 medalists, and now this week, here in Barra do Pirai, we have 71 teams that are going to take part in the final of all of them. They're going to launch their rockets to see who is the best multi-stage polyethylene terephthalate bottle rocket launcher in Brazil. Of course, I'm really curious to know that distance to see those rockets flying. But for me, the most important thing of all is what these people invented, what they brought in terms of innovation, what they brought in terms of creativity in the basic little rocket that Patrick and I taught how to make a year ago. But before anything else, how does this journey work here in Barra do Pirai? It's not just a competition. There are lectures, there's a planetarium, and the teachers learn how to assemble telescopes, how to make solid propellant rockets. Take a look at this. This is the Ararina. It's a solid propellant rocket made from polyvinyl chloride pipe, developed by Patrick. And here we have more than 100, which were built by the teachers and the students. In a workshop that was held yesterday, I'm going to launch one of the first ones. Here there's a squib that goes inside it, which is a gunpowder trigger. When you connect it to electrical power, it fires, and then the rocket ignition starts. The sound of this is just beautiful. When you press this buzzer, it goes up.
Starting with the manual Duarte. Our ambassador is going to launch his rocket in 3. Launch!
I hope the others are better, huh? It's almost time for the rocket launches. Everyone is there getting ready, and I'm going to show you how this works. In practice, each group has a space to launch their rocket, which are these numbered lanes. Only students and teachers can be inside here. You have to observe. And outside there's a safety net, so nothing flies in. Anyone watching, anyone here, has to wear personal protective equipment. A mask, a lab coat, and long pants, because a bottle can even explode, and that actually happens here. There's a huge space for the rocket to fly. This is a runway that's about 700 meters long. Very few rockets manage to get all the way to the end. And after everyone launches their rockets, a measurement is taken. All the teachers go out together to keep an eye on each other and start measuring the distance of the rockets. But no one says what the measurement was. That's a secret that's only revealed at the award ceremony. In this multi-stage category, the rules are pretty flexible, so people make rockets in very different ways. So as they start arriving here to launch their rockets, we're going to take a look at what kind of innovation they've added. At the same time, watch the launches, which is what really interests us. Let's go. Each team brings a different rocket base. They bring their own base. There's already a hammer waiting for them there. Then they prepare the rocket, set it up, and then they have to pump. They have to pump the compressed air. That gets really tiring and takes a while. I don't know, maybe 5 or 10 minutes pumping really hard. Many newcomers are just 13 or 14 years old, lacking strength and needing to use their weight. Do you want to apply extra pressure? Then it's dangerous too. If you put too much pressure, the bottle explodes. I saw at least 3 explode here today, but it's cool that everyone is protected. You can't get close to the rocket when it's highly pressurized, so there's an emergency valve there that you can use to release the pressure. Then, when you think you're ready to launch, you let the organizers know, and they do the countdown. When it's time to launch, you pull a string that releases the compressed air, and then the rocket goes up. Since it's a multi-stage competition, The second stage necessarily has to detach in the air. So there are two launches, one on the ground and another in the air. If that doesn't happen, the team is disqualified. It's also not allowed for the rocket to detach after it hits the ground. It has to detach in the air. So everyone really hopes that at least this separation happens in the air so the distance can be counted.
The fact that everyone's rocket detaches and they announce that it detached is an achievement. Because of the level of difficulty,
I expect about 250 meters, but we want to achieve more.
Well, the innovation we brought was the possibility to control the release of the second stage in the air. At the moment, we think is most beneficial for our launch. You just have to press the button and the rocket is released, so we have control over our rocket. Our expectation for the distance is to go beyond 200 meters, reaching around 250.
Well, basically the idea is a device made with a 3D printer which has a latch that will hold the second stage to the first stage, and inside our rocket there's a small electronic circuit that works as a timer. Tune you. With this timer, we make sure that the second stage will be detached at the most opportune moment.
Wow. But then why does it have this shape?
It's a rocket made with several bottles together, reinforced with fiberglass, made to withstand over 600 pounds per square inch, a 100% mechanical separation system, machined aluminum, carbon fiber, battery, carbon fiber.
Does it really fly far, or is it just for show?
It's made to fly. We've already managed 240 meters with less than a quarter of the pressure. We're going to use half the size, a heavier rocket proportionally, so it's promising. We had the idea, even before learning about two stages, to build a longer rocket that could handle higher pressure, since this is unprecedented in Brazil. So what? With this entry into the new category came the challenge of making a mechanism that not only separated the two stages, but did so at high pressures.
Today, I think the expectation is to reach about 450 meters.
They've started the countdown. We can see some markers out there in the middle at 50, 100, 200 meters. Anyway, what we're seeing here now won't be released at this moment. Only tomorrow we'll have the awards starting from here. These are the rockets that reached over 200 meters. That's pretty far. The last rocket went past the 500-meter mark, which was the last one, and now we're having trouble finding it here. Maybe it fell in the middle of the bushes. Nobody knows. Nobody saw where it landed. We think it's that object over there. Look, and it is. Not only did it go really far, but it pretty much stayed on the track, just a little bit more, and it would have landed in the bushes.
It's an absolute Brazilian astronomy Olympia record, absolute in all categories.
In all categories. You must have noticed that the level is high. People came up with a lot of different things. The rockets are going far, and now a good problem people are doing so well that we're running out of space to launch the rockets. And instead of going forward, we'll have to start thinking about going upward. The Brazilian Astronomy Olympiad launches have always measured the horizontal distance, so the launches are oblique, right? They go up at about 45 degrees, make a curve, and come down. That's cool because it's simple and easy to measure. If we launch vertically, there are two challenges. The first is having a parachute, because we can't predict exactly where that rocket will land. Nearly all professional rockets have systems to prevent them from crashing afterward. And the second thing, which might be even harder, is figuring out what height the rocket reached, what its apogee is. So there's this challenge of putting some equipment inside to measure that altitude, and Patrick has been working on this for a long time. He developed several models of very small, cheap, and lightweight boards that can measure the altitude. But not only that, some of them can even activate little motors, some servo motors for the parachute, to be able to release it at the moment the rocket reaches its peak, or a little after that. The idea is to put these boards, motors, the battery, and other components inside the rocket to measure altitude, making the equipment affordable and accessible to everyone. Here, at Brazilian Astronomy Olympiad, they're actually handing out these boards to everyone who's participating in the rocket journey. So to show exactly how this works, Patrick prepared some two-stage polyethylene terephthalate bottle rockets for vertical launch. Already, with this electronic device and some solid fuel rockets, we can see firsthand the tests of this technology, which should soon appear in Brazilian Astronomy Olympiad competitions. And, like with every new rocket test, there's no way to hold back the excitement. Will it launch? Will it record the data correctly? Will it explode? There's only one way to find out: by launching it, which is why we're here today. This is a demonstration rocket from Patrick for us to see. The vertical launch is very similar to the one we did a year ago, explaining how it works. The two-stage rocket works, with the difference that the first stage has a parachute, so it will come down gently after it separates. The second stage has the electronics, which will first measure the rocket's apogee, Measure the maximum height it reached, and second, release a parachute that's here at the tip. This will be done by a small motor, a servo motor that's down here, controlled by the board that's inside now. Rocket pointed upwards.
First stage with water, right? Up to 1/3. Okay, pins aligned and firm. Connection between the second stage system and the first stage. Okay, sealing system. Okay, parachute. Okay, pins aligned. Okay, vinegar, baking soda. Okay, electronics and parachute of the first stage of the second stage, in this case. Okay as well. So let's remove the RBF pin.
Does this activate the electronics?
It's the calibration phase. Status light on for 2 seconds, on for 2 seconds, off, ready for flight. Now it's time to pressurize over there, and it's the all or nothing moment, right?
Man, the kids struggled with this today. Now it's our turn.
That's my son. I'm going to exercise.
And it's not even sunny, huh?
Imagine in 40-degree heat, how many feet would there be?
50.
Let me check in the database.
It's already a bit over.
55, nearly 100, 150.
My view is angled, Patrick. It's already over 100, see?
Look here, it's showing 110.
What's up?
I think it's good. Is it good?
Is it?
Now's the moment of truth, right?
I won't overdo the pressure since I've seen bottles pop and rockets go off unexpectedly today. Let's play it safe, okay?
Exactly. There's always a limit, right?
Let's go.
Ready?
Let's count.
Attention for the Manual do Mundo multi-stage vertical rocket launch. Countdown. 5. Attention.
Oh.
It opened.
It opened.
Just didn't approve the internship. It didn't approve it. But electronics made up for it.
It was beautiful, it was beautiful. Man, that was amazing. The second stage didn't separate, so this is kind of dangerous. Hey, Patrick.
Hey.
What do I do? Do I hold the first stage, the second stage, and then let go, give it a kick?
No. Wait, did the balloon burst?
The balloon didn't burst, that's what happened.
I see, so there's no need to detach it, no.
Oh, okay, but it's not...
It didn't pressurize.
It didn't pressurize, so it didn't release.
Exactly. What rescued him was the electronics that detected the descent, even though it hadn't happened.
The disengagement.
The disengagement?
The electronics survived. Now, how many meters was it?
Yes.
According to the electronics, it was 45 meters and 60 centimeters, which would already be a 15-story building. That's a lot, right?
Yeah, and that was just the first stage, right?
Yeah. If it had been cleared, we could have gone about 60 meters. How?
60, 70 meters, there's more.
Shall we release Arena first then?
Let's go to the ball, because this one is Arena 2.0. It has a bigger engine with more performance than the ones you saw today.
So it goes farther.
Probably.
Let's go. Let's see Arena 2.0 Plus Premium Ultra Mega Power Flex. This superpower Arena has electronics, okay? It's going to be an oblique launch. It's more for us to see the rocket's behavior, then we'll launch it upwards. When Patrick says go, just touch this to the battery and whoosh.
Can we? Are we ready? Attention, Arena 2.0, solid propulsion, ignition in 3, 2, 1, ignite. And it kept going up.
Right? It was better than the first one. And this one wasn't even vertical. What did you think? It was oblique. Wow.
More power,
Unbelievable.
greater height.
Unbelievable. Let's launch it. Now, electronics will not only track height, but also deploy the parachute.
We wait, so be it.
If he retaliates, things will get complicated.
Ready?
Let's go.
Attention for the launch of the Colibri rocket, solid propulsion, vertical with recovery, ignition in 3, 2, 1, ignite.
Wow. The parachute opened.
It released the module and the parachute is going away.
The parachute went away, and the module fell.
People are good, right?
It's part of it. Right, it's part of it.
Do you think it withstood a direct fall onto the concrete?
Look! The nozzle melted here. That's expected, right? Patrick.
When you have a lot of exposure to heat, in this case, during the fall.
During the fall, it broke.
Look.
But
Could it be the electronics?
electronics looks like it's gonna survive, huh?
It's complete.
Let's see the peak here. 100, 151.5.
Exactly.
Patrick. Now that's not just any building, man. It's a beautiful building. Man, sensational.
Really cool, right?
Very nice, Patrick. Congratulations. This electronic setup has taken it to another level now.
It can even withstand a direct drop from 151 meters.
Amazing. Amazing.
Shall we launch another one?
Let's launch it, but now the line.
Ararinha rocket, version 3.0 with streamer, vertical flight, solid propulsion, ignition in 3, 2, 1, ignite! The effect of the streamer is to slow down the fall. It's simpler than a parachute.
Oh, isn't it a parachute?
It's a streamer.
What's the difference?
The streamer is a ribbon that serves to slow down the fall.
Oh, it's not a parachute.
Exactly. It's simpler to produce and prevents us from having too much lateral movement in case the parachute opens.
Ah, the parachute makes it slide too much.
Exactly.
It must be hot. Patrick, this one is scorching.
Ah, look, it's not a parachute, it's just a ribbon. Do you think this one was higher? No.
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 No, because he let go first, right?
Exactly.
Let's see, 86 meters and 90 centimeters. Not bad at all. Patrick.
Not bad, but it can get better, right? The idea of verticalization is exactly to allow us to make longer flights in slightly smaller places, since this parabolic launch, as you've seen here, has already exceeded expectations for available space.
Very good.
Everyone wants to have an airplane runway available, right?
Yeah, man, very good, very good. Congratulations, Patrick.
Let's keep evolving. In third place with 287.5 meters, Team 24. From Sumer, Sao Paulo, with Larissa, Mayara, Vivian, Natalia, and Manuela. Second place with 298 meters. Team 54 from the Educational Foundation of Coxham, Mato Grosso do Sul, with Peter, Diogo, Eduardo, and Lucas.
We saw history being made yesterday, and Pamela is here to prove that this number was the highest we've ever achieved in history, right?
All the levels in the rocket journey, this is the highest we've reached.
So, now I'm even going to use a cheat sheet here. We already know who won, because they were the only team left. It was Team 6 from Sorocaba, with 672 meters. Point 2. Let that be on the record.
With Peter, Giovanni, and Emanuele.
I've never liked the term influencer for YouTube content creators because it seems presumptuous and a bit arrogant to assume you actually influence someone. But regardless of that, here at Manual do Mundo, we really strive to be a good influence. So when I agreed to be an ambassador for the Brazilian Astronomy Olympiad, we decided to create a Manual do Mundo category. What we wanted was to see exactly what we're seeing now. People from all over Brazil, working hard, striving to develop new things, exercising creativity, learning not only physics and math, but also learning how to work as a team. And, maybe most importantly of all, learning to persevere to see things go wrong and keep trying. Seeing this materialize today, happening in practice, right here in front of us, is very special.